Hi there, I'm Timuçin. In this video, we are going to analyze that two surfaces actually, and let's see. Let's first see these two surfaces and make a comment about these surfaces. Okay, as you can see, when we try to compare these surfaces, one of them is depend on the left side image is depend on the smooth surfaces, well polished surfaces, and the right side is right image is depend on the more rough surfaces, and this roughness is due to the plastic deformation, the 35% tensile stress, and the white points on the dark background represents for the stands for the cells, and we can see in the roughness surface have more cells as a number, and the more polished, more smooth surface has uh, more low size cells and cell attachments with respect to the roughness surface. And in this video, we are going to measure, we are going to analyze, and we are going to point out the cell numbers. And during this analysis, we are going to use the ImageJ program, which is the free software. First of all, let me start with uh, smooth surfaces. And I just opened the image. I just opened the smooth surface image, and as you can see, there are some there are some uh, brilliant points, and there are some much more gray points, gray cells on the background, on the dark theme, and there I will just some arrangements for the easily seen, this easily distinguish these cells. First of all, I should arrange the type of the program, which is 8-bit, because this program is working in this criteria. And then I'm going to just arrange the, I'm adjust the threshold value. So as we can see, we can arrange the threshold value with this scale. So when I drag the parameter in the left side, in the right side, the surface is getting more complicated, and when I drag it to the right side, surface is getting more clear to observe clear in terms of the observing. But in this time, for this image, I'm going to set the lower threshold value as a 18. Okay, and that's it for now. And for second step, I'm going to use the process part of the program, and I go to binary subpanel and I'm going to convert mask to this. So this is type of taking screenshot for the next steps. And the second step is again in the process subtitle, and I'm going to go to again binary. Then I'm going to fill the holes. So I'm filling the holes to in order to make the other in order to make the next steps easy or clear. Then I'm going to use again process sub panel and again binary. Then I'm going to use the watershed, And this is the very critical steps for the process with using the watershed subpanel watershed tool of the program. It is possible to it's possible to distinguish the cells. It is separating the cells with using the separating tool, with using the watershed tool, let's say. Now our image is ready to analyze, and let's go to analyze subtitle and analyze particle. So in here we are going to analyze, we are going to see the number of the cells, and I'm adjusting the outlines in here, and I'm clicking OK. Okay, now with the from the results table, we can see the total number of the cells, which is on the smooth surface as a 179, and the other column is stands for the area of each cells in terms of the nanometer. So we can easily see that there are 179 cells on this surface, and we can see these cells and the nucleus of the cells as a red dots. And actually for this surface that's enough. And let me stay in here for the smooth surface. And now I'm going to open the what was that, the previous one, depend on the smooth. Okay, now I'm going to open the roughness surface, and then I'm going to follow the same steps for the analyze. Again, I just arranged the type as a 8-bit, and then I'm going to adjust to the threshold, and in this time I'm going to use 85 as a low threshold level. Of course, before the recording the video, I just make some practice, and this is the, I think, more ideal cases. And now it's okay. It is cool. Let me this term. Let me use red colors. The previous one was black and white, as you remember, and this time I'm going to use the red subpanel. And then I'm going to go to again process subpanel and binary and convert to mask. Again process binary and fill. I'm going to fill the holes. Then again process and binary, and then in order to distinguish the cells, I'm going to use the water sheets. Then it is ready to analyze it. Let me click on analyze, and then I just adjust the outlines, and I'm clicking OK. Don't save. Now let me first of all let me show that how many cells on the surface. As a cell there are 451 as a size. There are 451 cells, and the corresponding cells, we can see the area values in terms of the nanometer. And so the previous the smooth surface, at the smooth surface case there were 179 cells, but in the roughness surface case there are 451 cells, which is much more than the smooth surface. And we can also compare the processes, the cases in terms of this representation. So it is obvious that the cell size is much more than the smooth surface at the roughness surface. So again, we also show that the tabulated data in order to find the number of cells and the area of the corresponding area of these cells. So let me talk about the reason of this cell attachment, the differences of the cell attachment sizes. As it is obvious that it's obviously clear that at the smooth surface there are low cell attachments, but at the roughness surface, much more rough surface, the cell attachment is increased respectively, correspondingly. It is very clear, obvious. But the most important point is understanding the reason of these differences. So we can say that if we increase the roughness value of the surface, the cell attachment is also increasing. So how roughness was increased also, let me talk about also this topic. So to the surface, a plastic deformation is applied. So 35% plastic deformation tensile test was applied. With applying this plastic deformation, we are also playing with the surface property of the material. And then with the help of this process, we are playing with our roughness value of the surface. And as I said before, with increasing the roughness value, the cell attachment is also increasing. Why roughness value is affecting this cell attachment? Because with increasing the roughness value on the surface, the grooves some gaps are coming out, and due to this fact, cells are getting opportunity to uh, fill these gaps when we compare with the smooth surface. So we can say that the cells have more opportunity to fill, to attach the surface at the rough surface when we compare to the smooth surface. And this is end of my work and my presentation. Thank you for your attention.